Okay, so tomorrow we have a quiz. The quiz will be on lesson 6-1, 6-2, 6-3. It's going to have 10 questions. You will have 3 sometimes, always, or never questions. So make sure that you are understanding what all these segments in the triangles look like and what their points of concurrency are and where they're located. So one thing that may help you with that, remember we had this summary page that was in the notes from section 6.3. It was the last slide. So it talked about all of the different segments that you should be familiar with, what their point of concurrency is, and then the property or the theorem that is applicable to each one of these points of concurrency, and how to create each of the segments. So this was from the notes. So again, 3 sometimes, always, or never questions. The other 7 questions are going to be calculations. You will not have a proof tomorrow. So it's just basically going to be applying all of these points of concurrency and when do they make congruent pieces. Are they equidistant from the vertices? Are they equidistant from the sides? And be able to find the different points of concurrency. So let's go ahead and go through the warm-up first. I've also added another question at the end because you will have to write an equation of a perpendicular bisector. We did this in chapter 3, and I told you in chapter 3 I would not test or quiz you on it, but now it's back again in chapter 6, so you will have it on your quiz tomorrow. So we will do an example of that. So let's go ahead and do the warm-up answers first, because again, remember, even though there is a quiz review posted, don't always just focus on the quiz review. Go back, use your warm-ups, use your notes, any examples or things that I've provided for you. So let's go ahead and take a look at number 1. And this was from the 6-1 lesson where we learned about the perpendicular bisectors. So I can tell in figure 1 that AC has been bisected, and it's actually been bisected by a perpendicular segment here because of the right angle and the 2 congruency pieces. So I learned from my perpendicular bisector that any point that is on that perpendicular bisector is going to be equidistant from the endpoints of the segments. So what that means is that this piece here is going to be congruent to this piece here. So in order to find the length of AB, I need to find x first. So I'm going to set 4x minus 7 equal to 3x plus 1. I'm going to move the 3x to the other side. I get 1x minus 7 equals 1. Add the 7. X equals 8. Now it didn't ask for x, it asked to find the length of AB, and AB is equal to 3x plus 1. So I'm going to take what x equals and plug it in here. So I'm going to get 3 times 8 plus 1 gives me 24 plus 1. So the length of AB is 25. I'm going to apply the exact same thing on the next question. Again, notice AC has been bisected. It's got the 2 congruency marks here, and it's got the right angle. So I know that this was a perpendicular bisector. And again, I know that any point on that perpendicular bisector is going to be equidistant from the endpoints, and the endpoints are A and C, of the segment it was bisected. So this makes the 5x plus 7 equal to the 7x. So that'll be my equation that I set up to solve. I'm going to go ahead and subtract 5x from both sides. And I get 2x equals 7. Divide by 2. And x equals 7 over 2. Now you could make it a decimal or a mixed number. But again, we don't want just x. We need to plug it back in because it wanted AB. And AB is right here. It's 7x. So I'm going to take out x, replace it with what I just found, x equals. I can put a 1 under the 7 and now multiply straight across. And AB is equal to 49 over 2. You can leave it like that. You can divide it. make it a mixed number, or even a decimal. I would accept all three answers here. So this one, I learned that when an angle has been bisected, that any point on that angle bisector will be equidistant from the sides of the angle. And I can see I have two equidistant segments here, right here and here. So that tells me, using the converse, that this angle here was bisected. So I know that this piece is going to be congruent to this piece. So to find the value of x, this one just wants x. I'm going to go ahead and set 4x minus 8 equal to 3x plus 4. Subtract the 3x. X minus 8 equals 4. Add the 8. And x equals 12. And I'm done. It didn't ask me to go back in and find any angle measures. It just said find x. Now for the next one, notice the congruency marks on the angle. So this tells me that this angle here has been bisected. I also have some distances here. Since this angle was bisected, then I know that these two segments here are going to be equidistant. So I know that a distance is always perpendicular. So that would make this little angle here, the 4x plus 10, a right angle because it's always perpendicular. So to find the value of x, I'm going to set 4x plus 10 equal to 90. Subtract the 10. 4x equals 80. Divide by 4, and x equals 20. And x equals 20. So in 6.2, this is where we learned about the points of concurrency. And again, that slide from yesterday's notes will be beneficial if you're not sure which name goes with each point of concurrency. So for this one, it says, in this diagram, the perpendicular bisectors of triangle ABC are meeting at point G. What is that point called? So you need to know that the point of concurrency for the perpendicular bisectors, and in this figure, it's point G, is called the circumcenter. So now we know that if you were to identify here, let me show you which ones are the perpendicular bisectors. So my perpendicular bisectors, I'm going to highlight in red, and the perpendicular bisectors are going to be FG, EG, and DG. These are the perpendicular bisectors. So then that tells me that D is a midpoint. It also tells me E is a midpoint of side BC. So when it's been bisected, remember it makes two congruent pieces here. So if this side here is 5, then this side here is also 5, which is one of the questions. It asked me to find the length of EC. So I know that because GE was the perpendicular bisector, it has split BC into two congruent little pieces. Now F is also a midpoint, so FC and AF would also be congruent, but I don't need that. I need to now go back and find the length of GC. So GC, remember that from this point of concurrency, from the circumcenter, we can draw segments to each vertices and they're equidistant. So the equidistant segments from the circumcenter, remember, go to each vertice. So each one of these red lines are going to be congruent. So if BG is 7, so is GC. So you just need to memorize the theorems and what happens when you find that point of concurrency. So the point of concurrency here is the circumcenter, and from that circumcenter where all of the blue lines have met, I can draw segments to each of the vertices and they're going to be equidistant. So that's why GC is 7. So for the next one, it says in this diagram, The angle bisectors of triangle XYZ meet at point D. What is point D called? You're going to memorize here that the point of concurrency of the angle bisectors is going to be called the incenter. And we learned that once you find that incenter, and it's going to be point D here, so all of the red lines here are my angle bisectors. Remember, the angle bisectors are not congruent. What's going to be congruent are the equidistant segments to the sides that we can draw out of that incenter. So AD, BD, and CD are not perpendicular bisectors. They're just equidistant segments to the sides. In this question, it's telling me the length of AD. AD is right here, and they told me it's 10. So if this one's 10, then so is CD, and so is DB. So these are all the equidistant segments from that incenter, so DB equals 10. Lines, all of these are the equidistant segment, and they're all 10. 6.3, this is where we learned about medians and altitudes. The point of concurrency of the medians is called the centroid. Remember, this is the only one that doesn't make congruent segments. It's the 2/3, 1/3. So for this one, what we're going to do is, and again, this is the point of concurrency of the medians. So for the first one, they're giving me the length of BG. And BG is right here. And they're telling me this little piece is 9. They want me to find the length of the entire median. So remember, this 9 is the 2/3 portion. It's coming out of the vertice to this centroid. And then over here would be the 1/3 part. So in order to find BF, I can set BG is equal to 2/3 of BF. So BG is 9. So then I'll do 2/3 of BF is equal to 9. Whenever I see a fraction next to a variable, in this case my variable is BF, I need to divide. So when I divide fractions, I'm multiplying by the reciprocal. So the reciprocal of 2/3 is 3/2. So that's what I'm going to multiply both sides by. And then I get 27/2 is the length of BF. You can either leave it like that, make it a mixed number, or make it a decimal. So BF, 27/2, 13.5, or 13.5. Here, BD equals 12. So this one over here is 12. Find AD. Well, I know that when I create a median, D is my midpoint. So if this side is 12, then this side is 12. So AD equals 12. And then the third one here, they're giving me the length of CD, which is the entire median. They want me to find GC, which is the 2/3 part. Because again, the 2/3 part is from the vertex to the centroid. So in order to find GC, I'm going to take GC is equal to 2/3 of the whole thing, which is CD. So GC equals 2/3 times 27, and I can make it a fraction. I'm going to simplify diagonally and change this to a 9, this to a 1, and now the length of GC is equal to 18. So this one wants us to find the coordinates of the centroid. So remember yesterday I taught you a trick. Now, you could draw in and find all the medians by finding the midpoint and draw the segment from the vertex to the midpoint, but I'll show you the shortcut. We first need to figure out the 3 order pairs here. So the order pair for B is the order pair 1, 5. A is -3, 1, and C is 5, -3. So my shortcut, instead of drawing in all the medians, would be to add all the x's, divide by 3, add all the y's, divide by 3. So now I could draw in all the medians. So I've got a median right here. It's going to this midpoint. I've got another median right here. Goes from the vertex to the midpoint. And then I can draw in the last one. It's going to go from here to here. And you can see the point of concurrency is the 1, 1. But I'm going to show you the shortcut. We're going to take all of the x's. I'm going to add them. So -3 plus 1 plus 5, divide by 3. And then all of the y's, add them. So 1 plus 5 plus -3, divide by 3. The purple gives me 3 over 3. The blue gives me 3 over 3. Once I divide, the order pair is 1, 1. So you can do the trick. If it only asks you to find the centroid and not actually graph it and draw in the medians, you can do it that way. This is especially beneficial to do the trick when it's a fraction. And then the last one here, which type of triangle has its orthocenter on the triangle? And when it's on it, it's a right triangle. Yeah. On the quiz tomorrow, I am going to give you graphs on 2 of the questions. So there'll be a question where, I'm going to show it to you in a minute. I'm going to ask you to write the equation of the perpendicular bisector. I give you a graph for it if you want to graph the segment. Okay, you do not have to use either of the graphs that are on the quiz. They are just there if you want to use them. So the next question, and this isn't in the warm-up, I'm done with the warm-up now. The question is, find the equation of the perpendicular bisector with endpoints. X is -3, 4, and Y is 9, 8. So remember, steps 1 and 2 can be mixed up, but I'm going to find the midpoint first of XY, and then I'm going to calculate the slope. So -3 plus 9, divide by 2, 4 plus 8, divide by 2. The coordinate of my midpoint is going to be 3, 6. This is the midpoint because remember, the perpendicular bisector hits the midpoint because it's splitting this segment into 2 congruent pieces. Step number 2 will be to calculate the slope of the original 2 order pairs. And remember your slope formula, y2 minus y1 over x2 minus x1. 4 over 12 simplifies to 1/3. Remember, perpendicular lines have opposite reciprocal slopes. So now what I need to do is change this to the perpendicular slope, which is opposite sign. So I'm going to make it negative and then flip it to the reciprocal. I'm now going to take my newly found perpendicular slope along with my calculated midpoint and plug these into y equals mx plus b. So now take that, y equals mx plus b. I'm solving for b. So I'm going to replace y with the 6. This is my x and y. 6 is equal to -3 times 3. I'm finding the b. I'm going to add the 9. 15 equals b. And now I take my newly found b along with my perpendicular slope and plug it in to y equals mx plus b again. This time I leave the x and y, negative 3x plus 15. And that's your answer. Be able to do this tomorrow. Now on Canvas is this quiz review. And there aren't any real life application problems. So if you're going to use this to study, you can get rid of 13 and 14 and then just focus on the rest. Remember, if I give you a perpendicular question, perpendicular bisector, and I ask you to find the circumcenter, or if I give you a question to find the orthocenter, remember, that's always, I'm only going to give you a right triangle. So memorize the location for those. For the circumcenter, it's always on the hypotenuse, it's the midpoint. And for the orthocenter, it's always located at the right angle. So 10 questions tomorrow, no official homework to turn in. Your only homework is to study.